Ever catch yourself wondering, why some hours feel like they're over in a flash while others just drag on like you're wading through molasses?
Oh,
I don't.
definitely. That feeling is universal, I think.
Right. But what if that feeling, that personal clock of yours, isn't just a quirk of your mood? What if time itself is a bit more, well, bendy than we tend to think?
Now you're getting into some really interesting territory.
Welcome to the deep dive. Today we're plunging into the wonderfully weird concept of time, all thanks to some fascinating bits from the book Welcome to the Universe, an astrophysical tour.
hmm A great source. Takes these huge cosmic ideas.
And somehow makes them, well, surprisingly down to earth. It's a fantastic read.
Absolutely. What's great about Welcome to the Universe is its grounding in actual science, stemming from a popular university course,
Yeah.
but it's presented in a way that doesn't require a physics PhD to grasp.
Exactly.
And you're right, within its discussion of the cosmos are some truly remarkable insights into the nature of time that I think people will find really intriguing.
Definitely. It got me thinking the other day. I was trying a new recipe, this elaborate thing with, precise simmering times.
Okay.
And I swear, the 5 minutes the recipe called for felt like an eternity.
Just
Endless.
I know that feeling, waiting for water to boil, maybe.
Totally.
Yeah.
Then later, I was engrossed in a, let's just say, a gripping documentary about garden gnomes, believe it or not.
Garden gnomes, okay.
And suddenly an hour had just vanished. Poof! It's like my internal sense of time has its own bizarre agenda.
Right, that subjective experience is so common.
And this book, it really gets into why our intuitive understanding of time might not be the whole story. So get comfortable, because we're about to take a relaxed, conversational stroll through some of the truly surprising aspects of time, as revealed in this fantastic resource.
Sounds good. Where should we start?
Okay, so let's dive right into a concept that really shakes up our everyday assumptions: the relativity of time.
This is fundamental, stemming from Einstein's theories, special and general relativity, both of which pop up in the book. We tend to think of time as this universal constant, right? Like a big clock in the sky ticking away uniformly for everyone and everything.
Yeah, like Big Ben for the whole universe.
Exactly. But relativity tells us that time is actually relative to the observer. It depends on how you're moving and the gravity you're experiencing.
Right, that's the bit that always kind of blows my mind. It's like we all have our own personal timelines, and they're not always perfectly in sync.
Precisely.
I remember once imagining, just playing around with the idea, where I was on a ridiculously fast spaceship, hurtling through space at nearly the speed of light.
Okay, classic thought experiment.
And I pictured coming back to Earth to find that my imaginary pen pal who stayed behind had aged way more than I had. It sounds like something straight out of science fiction, doesn't it?
It really does.
Hmm.
But the book explains the underlying principles, the physics, that make this thought experiment not entirely outlandish. It's based on real science.
So how does that work?
Well, if we look at the book's explanation of special relativity, it hinges on something crucial. The speed of light in a vacuum is constant for all observers. It doesn't matter how fast you're moving or how fast the light source is moving.
Okay, that constancy is key.
It is. Now think about that for a second. It had some pretty wild implications. To keep the speed of light constant for everyone, even those moving at different speeds relative to each other, something else has to give. And that something is time itself. For a moving observer, time will actually pass more slowly relative to a stationary observer. It's called time dilation.
So if I'm on that super speedy rocket with my imaginary astronaut suit on, right, and I shine a laser pointer ahead, the light still zips away from me at the speed of light as it would if I were just sitting here sipping my, mental tea.
Correct.
But for my stationary friend watching me zoom by, my clock, and therefore my experience of time, my aging, everything would appear to be running slower than theirs.
That's exactly it. It's completely counterintuitive to our daily experience, but it's a confirmed consequence of how space and time work.
Wow. Okay. That's special relativity. Does the book connect this to, like, visualizing it?
Yes, it does. The book also introduces the concept of a space-time diagram. It's a really helpful way to visualize this interconnectedness of space and time.
FaceTime. One word.
Right. Instead of thinking of them as separate and independent, relativity shows us that they are intertwined into a single four-dimensional fabric called space-time.
4 dimensions. Okay.
The book uses the example of Earth orbiting the Sun. On a space-time diagram, this isn't just the Earth moving through space. It's tracing a continuous path, a kind of line called a world line, through this combined space-time.
Oh, like a never-ending cosmic ribbon just winding its way through
Yeah.
existence. That image actually really helps solidify it.
Exactly. It's a path through both space and time. And from this idea of space-time comes another fascinating concept the book touches upon, the loaf of space-time analogy.
A loaf, like bread.
Sort of. Imagine the entire history of the universe, every single event that has ever happened and ever will happen, all contained within this single four-dimensional block, or loaf.
Okay. Got the loaf in my head.
Now, different observers, say you here on Earth and our hypothetical astronaut rocketing through space, are essentially taking slices through this loaf,
Yeah.
but at different angles.
Different angles because they're moving differently.
Precisely. Each slice represents what that observer considers to be their present moment, their definition of now, basically the collection of events they perceive as simultaneous. But because their relative motion is different, their now slices don't align perfectly.
Whoa. So my experience of, say, a Tuesday afternoon spent finally sorting my sock drawer
Mm-hmm.
might include events that my speedy astronaut friend sees as happening on their Tuesday morning navigating an asteroid field, or even their Monday night calibrating the warp drive.
That's the implication. What constitutes simultaneous events depends on your frame of reference, on how you're moving through space-time.
It's like our realities, our presents, aren't quite the same. That's truly bizarre and yet kind of elegant, you know?
It is elegant. It replaces the idea of a universal now with a more flexible, observer-dependent reality.
Okay, so movement affects time. But what about gravity? You mentioned that too. The book touches on that, right? General relativity.
Yes, that leads us into Einstein's theory of general relativity. The book explains how massive objects don't just exert a gravitational force in the way Newton described it, like an invisible pull. They actually curve and warp the fabric of space-time itself.
Ah, the trusty trampoline analogy. I knew it would come up.
It's a good one. Think of placing a bowling ball on a stretched rubber sheet. The sheet dips around the bowling ball.
Right, it creates a curve.
And if you roll marbles nearby, their paths will be curved by that distortion. They follow the curve.
Okay.
Massive objects do something similar to space-time. This curvature dictates how objects move within that region. Planets orbiting stars, for example, and it even dictates how light travels. Light has to follow the curves, too.
So, the bowling ball, representing a massive object like a star or planet, creates a dip in the trampoline, space-time, and anything rolling by gets pulled towards it, not by an invisible string, but by following the curve in the surface itself.
Exactly. Gravity isn't so much a force as it is the geometry of space-time being warped.
And I remember the book hinting that this warping of space-time also affects time, even if it doesn't get bogged down in the really heavy math.
Precisely. While the book might not delve into all the intricate equations of general relativity within the excerpts we're focusing on, the fundamental concept of gravity as a curvature of space-time is clearly established.
Okay.
And this curvature has a direct impact on the passage of time. In regions of strong gravity, where space-time is significantly curved, like near a very massive object, say a neutron star or a black hole,
Yeah.
time actually passes more slowly compared to regions with weaker gravity, like out here in interstellar space, or even just further away from Earth.
So wait, time runs slower closer to Earth than it does for, say, a satellite way up high.
Yes, infinitesimally slower, but measurably so, with precise enough clocks. GPS satellites actually have to account for both special relativistic effects due to their speed and general relativistic effects due to being in weaker gravity to stay accurate.
Wow. Okay, so it's not just theoretical, it has real-world applications. So if I were hypothetically brave enough to hang out near a black hole, which, spoiler alert, I am absolutely not,
Wise decision.
a minute for me in that extreme gravitational environment might feel subjectively the same, but back on Earth, maybe years would have gone by, or centuries, depending on how close I got.
That's the essence of gravitational time dilation, yes.
Yeah.
The stronger the gravity, the slower time flows relative to an observer in weaker gravity. It's another pretty profound effect.
It really is. Now, the book doesn't just leave us with these cosmic head scratchers, does it? It also brings it back down to Earth, in a way, by talking about our place in the vastness of cosmic time.
Exactly. It makes a nice transition from these fundamental principles governing time to our human experience of it, placed within the immense backdrop of the universe's history.
Yeah, I remember this one anecdote that really stuck with me. The book mentioned that if you make it to the ripe old age of 31 years, 7 months, 9 hours, 4 minutes, and 20 seconds, approximately,
Quite specific.
you've officially lived for 1 billion seconds.
Billion seconds.
And apparently, someone actually marked that milestone with a celebratory mini bottle of champagne, which I thought was pretty cool.
That's fantastic. It really makes you think about the sheer number of moments of seconds that make up a life, doesn't it?
It really does. Suddenly, that 5-minute simmer time or my fleeting fascination with garden gnomes seems utterly, utterly insignificant against that kind of cosmic clock.
It truly puts our everyday experience of time into perspective when you consider the vast timescales over which cosmic events unfold. We're talking about the lifespans of stars, the evolution of galaxies, processes that occur over billions and even trillions of years.
Yeah.
Our human timescales are just a blip.
A tiny blip. And it also highlights the more immediate rhythms that shape our lives, like the Earth's journey around the sun. I recall the book having a clear illustration of how the Earth's tilted axis gives us our seasons.
The tilt is key.
Right, how different parts of the planet receive more direct sunlight at different times of the year, leading to those long summer days and short winter nights, depending on your hemisphere.
It's a tangible example of how our experience of time, even just on an annual cycle, is deeply connected to our planet's movement through space, its dance of the sun.
Yeah.
That cyclical nature is so ingrained in our lives, isn't it? From the rising and setting of the sun defining our days to the changing seasons marking the years.
Absolutely.
But the book gently pushes us to consider the much grander cycles at play in the universe. It touches on the life cycle of our own star, the sun.
Oh, right, the future forecast.
Yeah, how it will eventually swell into a red giant, probably engulfing the inner planets, including Earth.
Cheerful thought.
Well, it's billions of years away, before eventually fading away as a white dwarf.
Billions of years in the future. Phew. Okay. Still, it's that slow, inevitable cosmic dance. It's a powerful reminder that even something as constant feeling as our sun has a beginning, middle, and eventually an end on these enormous timescales.
It makes you feel both incredibly small, perhaps, but also part of something so unimaginably vast and dynamic.
Yeah, that's a good way to put it.
And if we bring it full circle, even these colossal cosmic processes, the birth and death of stars, the interactions of galaxies, all unfold within that framework of space-time, governed by the very principles of relativity that we discussed earlier, motion and gravity shaping the stage.
So if we try to sum it all up, it sounds like time isn't this rigid, universal metronome just ticking away the same for everyone, everywhere.
Definitely not.
It's fluid, it's flexible, it can be stretched and squeezed by motion and gravity like taffy.
Space-time taffy, I like it.
And our personal experience of it, our lives, our Garden Gnome documentaries,
Yeah.
it's all just a tiny, fleeting moment within the immense panorama of cosmic time.
That's a pretty accurate summary.
It's enough to make your head spin, but in the best possible way, right?
It truly is a mind-bending perspective.
Mm.
And, when you consider how our understanding of something is fundamental as every day as time has been so radically transformed over the last century or so,
Yeah.
it certainly makes you wonder what other seemingly fixed aspects of our reality might hold equally surprising secrets just waiting to be uncovered.
Mhm.
What else do we think is constant that isn't?
Exactly. That's a fantastic thought to end on. What else are we taking for granted? So, if this deep dive into time has sparked your curiosity, and I really hope it has, we highly recommend checking out Welcome to the Universe for an even richer exploration of these fascinating concepts.
It's a worthwhile read for sure.
Thanks for joining us for this look into the wonderfully weird world of time.